everyone. My name is Sriram from the Department of Artificial Intelligence and Machine Learning, Savita Engineering College. I'm going to present my project titled Oil Spill Reduction in the Marine Environment. In this presentation, I'll cover introduction and problem statement, scope of the project, methodology of the system architecture, the algorithms used, implementation details, results and outputs, and my conclusion on future work. Oil spills are one of the major environmental threats to marine ecosystems. They affect marine biodiversity, fisheries, coastal regions, and land economics. In this project, I propose an AI-based oil spill detection system that integrates satellite imagery, mainly Sentinel-1 SAR data, and AIS vessel tracking data. Using deep learning, the system automatically detects oil spill regions and correlates them with nearby vessels to identify the portable sources. The problem statement. Monitoring oil spills are difficult to the very vast size of oceans and limited surveillance. The major challenges include differentiating oil spills from similar dark features like how wind zones and organic films, limited later labeled datasets from training DL models, difficulty in detecting responsible. The goal of this project is to build a future-based AI model that detects oil spills from satellite images. Moving on to the scope of the project. First, oil spill detection uses satellite imagery. We use SAR and optical satellite data such as Sentinel-1, Sentinel-2, and Landsat to detect dark patches, smooth surfaces, and abnormal reflectance patterns. Second, integration of AI's data, where vessel movement, speed, and behavior are tracked to identify suspicious activities related to illegal oil discharge. The third, automated image processing and classification using CNN or unit models to classify spill and non-spill regions. Next, the system supports real-time or near real-time monitoring where alerts are triggered when abnormal satellites and AIS patterns are detected. It also supports AIS-based spatial analysis, allowing visualization of oil spills and vessel tracks on maps. The project also acts as a decision support system for coast guards and environmental authorities. It is designed to be scalable, meaning it can monitor multiple marine regions and integrate more sensors in the future. Finally, the system stores historical spill data, which helps in trend analysis, prediction, and environmental studies. So, the methodology consists of 7 steps. First, the data collection, pre-processing, then feature extraction. Next, oil spill is done using CNN or unit models. Then, AIS and satellite data integration is performed to match spill locations with vessel tracks. After that, visualization is done using GIS maps. Finally, alerts and reports are generated whenever a spill is detected. So, the architecture diagram this shows the overall system architecture. Satellite data and AIS data first go through pre-processing, then feature extraction, and oil spill detection are performed. The outputs are integrated, visualized, and finally reports are generated for authorities. The design diagram, both functional and structural design. Moving on to the algorithms used. The main algorithm used is the convolutional neural network or CNN. CNNs are well suitable for image data. They automatically learn visual features like edges, textures, and sharp shapes. In oil spill detection, CNN learns the unique spectral and textural patterns of oil spills, which appear as smooth and dark regions in SAR images. So we'll see the CNN working. The CNN consists of convolutional neural networks for feature extraction, pooling layers to reduce dimensionality, ReLU activation for non-linearity, fully connected layers for classification. The final output classifies the region as either oil spill or no oil spill. Compared to traditional methods, CNNs provide higher accuracy and better generalization. Apart from CNN, the project uses image segmentation from UNet, thresholding algorithms it processes whether object detection models like YOLO or faster RCNN, machine learning classifiers such as random forest or SVM. Moving on to the hardware. Hardware includes satellite imaging systems, AIS receivers, GPU, or high performance computing nodes. The software tools include Google Earth Engine or Snap for pre-processing. We can also use PyTorch or Cetera for deep learning, QGIS or ArcGIS for visualization, Python and SQL databases for processing and storage. Implementation overview. So this is the interesting part. During implementation, SAR images are fetched using Sentinel Hub APIs. AIS data is collected from AIS providers. Both datasets are fused spatially and temporarily to identify spill vessel relationships. Model training. The CNN model was trained around 5,600 labeled SAR image patches. Class labels imbalance was handled using weight loss functions and balanced sampling. The final model achieved approximately 93% accuracy along with confidence scores for predictions. AIS anomaly detection. AIS data is pre-processed to extract behavior features like speed, acceleration, course changes, loitering patterns. Here you can see sample outputs for. So this is the code segments, which is very common. So here you can see sample outputs for Chennai coast, San Francisco coast, Sicily, Chennai coast, San Francisco coast, Sicily in the Mediterranean Sea. The system correctly identifies oil spills and non-oil spills regions across different geographic locations. Results. The result shows accuracy around 90 to 93%, high precision and recall, faster and effective predictions compared to manual methods. Conclusion. To conclude this project, the project successfully integrates Acclaim Imagery and AI's data to automatically detect oil spills and identify possible source vessels. It reduces dependency on manual inspection and improves detection using accuracy under different sea conditions. This system demonstrates the strong potential of AI and data fusion in marine environment surveillance. So, our future work includes using advanced models like ResNet and EfficientNet, applying transfer learning, improving evaluation metrics, deploying the system as a real-time web